All right, let's get right into it. Today, we're talking about the absolute heart of Java programming. I mean, the real core of it all. Classes and objects. These are the fundamental building blocks you're going to use to create, well, pretty much everything. So yeah, let's dive in.
Just think about it for a second. Have you ever wondered when you're playing a video game and there are like 100 different enemies on the screen at once? Or when you're scrolling through an online store with thousands of products? How in the world does the software keep track of every single one? Each one has its own health, its own price, its own location. How is that even possible without becoming a total mess?
Well, the answer to managing all that chaos is actually surprisingly simple and kind of elegant, really. It all boils down to one powerful concept, a metaphor we're going to keep coming back to, the idea of a blueprint.
So let's really dig into this blueprint idea. In this first section, we're going to break down exactly what a code blueprint is, and just as important, what it's used to create. This is the one distinction that, once you really get it, everything else in Java just starts to click into place.
This slide just lays it all out perfectly, doesn't it? On the left, you've got the class. That's our blueprint. It's the plan, the template. It's just a logical idea. But then on the right, you have the object, and that's the actual building. It's a real thing, a tangible instance that you create from the blueprint. It has its own state, and it can actually do things. So let's make it official. A class is simply the template. Seriously, think of it like the architect's drawings for a house. The drawing defines that the house will have doors and windows. Those are its properties, or what we call fields. It also defines that you can open the doors. That's a behavior or a method. But here's the key. The drawing itself is not a house you can actually live in. It's just the plan. An object, on the other hand, is the house. It's what you get when you follow the blueprint. It's a specific concrete instance. It has a state, like the front door is painted red, the window is currently open. It has behavior. You can literally go and open that door. And it has an identity. It's the house at 123 Main Street, which is totally different from the house at 125 Main Street, even if they were built from the exact same blueprint.
Okay, so we've got our blueprint, our class. That's great. But how do we actually, start construction? How do we build the house? Let's take a look at what that actually looks like in Java code.
This one little line of code might look pretty simple, but it's actually doing three totally separate things. First up, student S1. That's the declaration. You're just giving Java a heads up saying, hey, I'm going to need a variable named S1 that can hold a student object. At this point, no object even exists. Then, new student. This is the magic moment. This is instantiation. The object is actually built in your computer's memory. And finally, that little equal sign, that's initialization. It connects your label S1 to that brand new object you just created. So the really crucial part of all that is the new keyword. You can basically think of it as the magic wand for making objects. It's the command that tells the system, hey, go find some space in memory in a special area called the heap and build me one of these student things right now. It's the key that turns that logical blueprint into a real thing inside your computer. Okay, so our object exists. We've built the house. It's sitting there in memory. But a house you can't interact with isn't very useful, right? It's just a box. Now we need to define what our objects can actually do. And this is where behaviors, or what we call methods, come into the picture. This quote really sums it up perfectly. A method is how we let our object show off its behaviors to the rest of the world. It's the open door button. It's the calculate area action. It's the deposit money function. It's how we make our objects come to life and actually do useful stuff. And why do we even bother with this? Well, there are two huge reasons. First, code reusability. It's a game changer. You write the logic for calculate area just one time inside your class, and then every single object you make from that class can use it. No more copy and pasting code. And second, it just makes for cleaner, more optimized code. It keeps all the related actions bundled up with the data they're supposed to work on. Here's a great, super simple example. We've got a class, our blueprint, called rectangle. It has two properties or fields, an int for length and an int for width. And it has one behavior, one method called calculate area. And its job is really simple. Just multiply its own length and width and print it out.
Okay, now let's see it in action. First, we use our new keyword to create a rectangle object called R1. Then, we use a method to set its state. We give it a length of 11 and a width of 5. And finally, with r1.calculateArea, we use that little dot to tell our object, hey, R1, it's your turn. Run your calculate area behavior.
And boom, there's the result, 55. The calculate area method did exactly what it was told, using the specific data inside the object R1, 11 times 5, and printed the result. See how the object's data and its behavior are tied together? It's crystal clear.
All right, we've covered all the individual pieces, the class blueprint, the object instance, and the method behaviors. So now let's put it all together in one complete working program. We can see the whole process from start to finish.
So here's the whole setup for our program. We're defining a student class, our blueprint. It's got properties for a roll number and a name, and it's got behaviors or methods to insert a record and to display its information. Then below that, the test student for class is where we have our main method. That's the starting line for our program, where we're going to actually put the blueprint to work.
So the very first thing our program does inside main is use that new keyword twice. We are constructing two completely separate student objects in memory. They're built from the exact same blueprint, sure, but they are their own unique things, like two different houses on the same street.
Now it's time to give these empty student objects some personality. We call the insert record method on our first object, S1, and we pass in the data for Quran. Then we call that exact same method on our second object, S2, and give it the data for Aryan. Right now, each object is holding its own unique information, completely separate from the other.
And now for the big reveal. To prove that they're separate, we ask each object to report back. We call the display information method on S1, and then we call it again on S2. Each object is going to look at its own internal data to figure out what to do.
And there it is. The proof is right there in the output. S1 correctly prints its own data, and S2 prints its own totally different data. This right here, this is the power of object-oriented programming. One single blueprint creating multiple independent objects, each one managing its own state. And this pattern is absolutely universal. You can see how easily this idea applies to something way more complex, like a real-world bank account, right? You'd have a property for the balance amount, and then you'd have methods, those behaviors like deposit, withdraw, and check balance. Every single customer's bank account would just be a separate object created from this one account blueprint. And what's really powerful is that these methods can change the object's internal data over time. The object has a life. You start with a balance of 1,000. Then you call the deposit method, and the balance inside that object goes up. Then you call withdraw, and the balance goes down. The object lives and changes based on the behaviors you tell it to perform. So there you have it. A class is the blueprint, and an object is the actual building you construct from it. These two concepts are the fundamental tools you need to build vast, complex, and really powerful software. So the only question left is, what incredible structures are you going to design and build next?